In this video, we will discuss using a normal distribution curve as a probability distribution curve. Because a normal distribution is continuous, there are no gaps in the curve. So for every z value, there is a corresponding frequency value. The area under a normal distribution curve can be thought of as a probability. If it were possible to choose a z value at random, the probability of choosing a z value between 0 and 2 would be the same as the area under the curve between 0 and 2 standard deviations. A special notation is used to denote the probability of a standard normal variable z. If the problem is to find the probability of any z value between 0 and 2.32, we write the probability as P of 0 is less than z is less than 2.32, or the probability of z between 0 and 2.32. Note the probability of any exact z value is 0 due to continuity, but vertical lines in theory have no area. So the probability that a is less than or equal to z, which is less than or equal to b, is equal to the probability that a is less than z, which is less than b. As an example, we will find each of these probabilities. First, we want to find the probability that 0 is less than z, which is less than 2.53. Per table E, the area under the curve corresponding to 2.53 is 0.9943, and the area under the curve corresponding to 0 is 0.5000. So the probability that z is between 0 and 2.53 is 0.9943 minus 0.5000, which is 0.4943, or 49.43%. Now we're looking for the probability that z is greater than 1.98. Per table E, the area under the curve corresponding to 1.98 is 0.9761. Since we are looking for the probability of z greater than 1.98, we subtract 0.9761 from 1. So the probability that z is greater than 1.98 is 1 minus 0.9761, which is 0.0239, or 2.39%. If we need to find a specific z value for a given area under the standard normal distribution curve, we work backwards using table E. If the exact area you are looking for can't be found, use the closest area. The area 0.9241 does not appear on table E, so we would use the closest area, which is 0.9236. For example, find the z value such that the area under the standard normal distribution curve between 0 and the z value is 0.2123. So here we have that. Since we are looking at an area between 0 and z, we must add 0.5000 to the area to get the total area under the curve up to z. That area is 0.7123. When we look up this value in the table, we find z equals 0.56. And I will just add that there would be another area here between 0 and the z value that would have this same area. But since they say 0 first, we're going to assume it's to the right of